Welcome, fellow aviators. Today, we are going to be reviewing the operational principles of the torque limiting system of the PT6 engine. While this system is not employed on all PT6 models, it is a critical safety feature for those that employ its operation. So, let's get into it. There are many airframes on which the PT6 engine is currently in use. While details will vary slightly between the various applications, the general principles will remain the same for all aircraft using the PT6. For the purposes of today's presentation, we will look at the details of the Pilatus PC-12 utilizing the PT6 Alpha 67 Bravo and Papa engines. Torque limiting systems are placed on some models of the PT6 to help the pilot avoid over-torquing and damaging the engines with excessive power settings. The PC-12 has many limitations that the pilot should be aware of, but today we are going to focus on the torque limitations. The PT6 Alpha 67 Bravo and Papa is limited to a max continuous power setting of 36.95 psi torque. Power settings above 36.95 psi can be selected by the pilot for takeoff or max climb scenarios. However, settings above 36.95 psi are limited to a maximum of 5 minutes operating time for Bravo models. Settings above 44.34 psi are not possible due to the torque limiter system. Some variation may occur as the system adjusts, especially during rapid power application, but in these cases, momentary torque values above 44.34 psi are acceptable, but should not last more than 20 seconds. If torque values exceed 61 psi, or the 20-second limitation, the torque limiter has failed and engine inspection is now required. To better understand how this could occur, let's take a look at how the system works. The PT6 is a free turbine split shaft design. That means there are two major sections of the engine. The gas generator is the section that burns the fuel to create engine rotation. This section of the engine is limited by maximum inlet turbine temperature constraints. The power turbine is the section that uses the exhaust gases from the gas generator to put the engine to work. This section of the engine is limited by maximum torque constraints. Power is a function of gas flow and revolutions per minute. Because of this, the most accurate way to get power readings from a PT6 is to take them from the torque production of the power turbine. This is accomplished at the first stage ring gear of the gearbox. The engineers tell us that the rotation of the first stage ring gear is resisted by helical splines, which impart an axial movement to the ring gear. In English, this means that when the power turbine spins, it tries to spin the first stage ring gear with it, but it can't because the first stage ring gear is keyed into the engine housing. These keyways are cut diagonally, so the first stage ring gear will begin to slip rearward as the rotational force is applied. To measure this torque, the first stage ring gear is attached to the torque valve. Oil pressure of approximately 100 psi is supplied from the engine-driven pump. Metered oil is allowed to pass through the torque valve. The higher the torque, the higher the metered oil pressure will become. As torque on the first stage ring gear is reduced, the metered oil pressure will drop. The metered oil is sent to the torque limiter and the torque sensor. The torque sensor compares the metered oil to the relief oil pressure. Some pressurized oil passes through a calibrated orifice that maintains oil flow and prevents vacuum lock in the system. Information from the torque sensor is sent to the engine indication system, where it is digitally displayed for the pilot on the torque meter. Many PT6 applications will translate this reading into foot-pound units or even percent of maximum power readouts, but Pilatus has chosen to leave this reading as metered oil pounds per square inch. So to review, as the first stage ring gear moves aft, metered oil pressure increases. This moves the torque sensor, and the pilot sees an increase in torque indication. As the first stage ring gear moves forward, the torque falls. If the torque rises beyond 44.34 psi, the torque limiter will activate to control engine torque settings. Metered oil pressure enters the torque limiter from the torque valve. As it does, it presses against a spring that is set to 44.34 pounds per square inch. The spring is sent against a bimetal washer that will contract when the oil temperature is cold and expand when the oil temperature heats up. Thus, it maintains a setting of 44.34 pounds per square inch at all temperature ranges. This unit is called the torque relief valve. The torque relief valve is attached to a plunger that holds PY air from the fuel control unit. If the pressure on the torque relief valve exceeds 44.34 pounds per square inch, the relief valve will lift and vent PY air. Because the fuel control unit uses PY air to control fuel flow, when PY air pressure drops, fuel flow drops as well. This causes engine power to fall until metered oil pressure is once again below 44.34 pounds per square inch. For more information on the fuel control unit operation, check out my video on the PT6 fuel control below. Thanks for watching. Like this video if you did, and subscribe if you haven't. We'll see you on the next one.